the relation between for all and a single implication, and there exists an and. So whenever we are using quantifiers, we always use a for all with a single implication, and there exists with an and. So the first thing which needs to be kept in mind is that the logic formula which we would be getting always has to be a tautology. So now let's take an example. So I have taken an example over here. Everyone in this class has taken calculus. So from everyone we can conclude that we have to use for all. And when a statement like this comes, like in this class, domain reduction needs to be used. So dr. Over here we are assuming that the domain consists of three people, P1, P2 and P3, where P1 and P2, they belong to the class, and P3 doesn't belong to the class. So if we write something like for all x, before that we need to make some predicates where px states x is in class and cx states x has taken calculus. So if we write something like for all x, if x is in the class, then x has taken calculus. If we expand this formula, that is as it is a for all, we would be using an and. So now we know that P1 is in the class, so this is true. C of P1, that means P1 has taken calculus, that is true, because we assume that the English sentence is always correct. That is, everyone in the class has taken calculus, so it means that P1 has also taken calculus, which makes it true. So true implies true means true. P of P2, that is P is in the class, so this is true again. CP2, again P2 has taken calculus, true implies true, which again gives true. P of P3, which is false. So now if this is false, this entire thing is true. So true and true and true, which again is true. This is a tautology. So what we have written is correct. Now, but if I wrote something like for all x, px and cx. Now if I expand this, so now I have expanded this. All of this till like over here is true, but this is false. Like P3 is false, and this may be true or this may be false. We don't know, but this is false, and there is and everywhere. So this entire thing is false. Hence we can't use a and with a for all. Now if I take another example with there exists. Now I took an example of someone in this class has taken calculus. From someone we can conclude that we need to use there exist. In this class means a domain reduction needs to be used. Over here again we take the domain as P1, P2 and P3. Again we take the same configuration where P1 and P2 belong to the class and P3 doesn't belong to the class. Now over here it has been stated that someone in the class, that means either P1 or P2 has taken calculus or they both have taken calculus. So for simplicity purposes I'll assume that P1 has taken calculus and we don't know about P3. P3 may have taken calculus or may not have taken calculus and we don't care. So if we start writing down in predicate form, we need to define the predicates first. Px again over here states P1 over here states that x is in the class and Cx over here states that x has taken calculus. So now writing it in logic form, you would say that there exists an x where x, Px and Cx. Now over here we are using an AND with for all. Why? Now just let me expand this and explain. So I've expanded this. Now P1 is obviously true because P is in class and that was an OR instead of an AND because over here there exists is being used. C of P1, that is P1 has taken calculus, we have assumed is true. So this is true. The whole thing gives true. This over here P of P2 again is true, but C of P2 is false. So this makes it false. P of P3 is false, so again this makes it false. But this gives true, so that means this is correct, as it is going hands in hand with the English statement which we wrote. But now writing something like there exists x, Px, implication Cx. Now this is wrong because if we expand it again, we will see. Now over here, P of P1 is true, C of P1 is true, so this implies true. P of P2 is true, which implies C of P2, this is false. So this entirely gives false. Now P of P3 is false and this may be true or this may be false, whatever may be the case, this would obviously give us true. But now again this gives us true. This is wrong. Why is this wrong, you may ask? This is wrong because over here we have taken the third case, which is P of P3 implies C of P3 as true. Logically it is correct, but according to our English sentence it is wrong. Therefore, with for all, we would always be using a single implication, and with there exist, we will be mostly using an AND. This is not a strict rule, but this is a generalization.